Hello, my name is Geertjan Wielenga. I work for the Oracle Developer Tools division focused on NetBeans. In this session, we're going to look at getting started with Java Enterprise development. In particular, we're going to look at the things to be aware of before you begin using Java EE. Java EE stands for Java Enterprise Edition, and it's the short form for Java Enterprise development. So we'll use the term Java EE throughout this session. In this session, we're going to cover the following agenda. First of all, we're going to ask ourselves the question, what is Java EE? Secondly, we're going to look at the problems that it tries to solve. Thirdly, we're going to look at what you need to use Java EE. And finally, we'll finish with some demonstrations. The first question is, what is Java EE? We're assuming you know nothing about Java EE, and this is your very first introduction to it. This whole session is focused on getting started with it without any prior knowledge, the very first steps into Java EE. First of all, it's very important to be aware that Java EE simply is a development platform. It's a set of frameworks, of specifications, of libraries, of tools that help you to create business applications that are deployed into the browser. It's not a framework that is used for creating mobile applications. It's not for creating developer tools on the desktop. It's not for applications that are deployed elsewhere. It's really focused on the browser. There are two parts really to Java EE. There's the back-end part and there's the front-end part. The front-end part, of course, could be deployed anywhere. You could connect to a Java EE backend from any front-end, including a desktop, a mobile application, and so on. But the focus really of Java EE in the first place is on providing back-end services that relate to standardization for the data access layer and for the business logic layer of large applications that are deployed into the browser. It's really business focused. So these are not games that are created with Java EE. These are business applications. For example, banking applications or air traffic control management applications. Typically, these are back office applications. They're also often used to customers, shown to the customers in banks, for example. So there's a whole range of different places where you might see Java Enterprise applications. All of these applications that make use of Java EE certainly make use of Java on the back end, in accessing the database, in working with business logic in between the database and the view layer. Java is used. On the front end, as stated, typically you would use from the Java EE platform the JSF specification, but you can also use, as an alternative, you could use HTML and JavaScript and CSS, which is something that we will also look at. What's most important about Java EE is that it's based on specifications and standards. A typical problem in creating applications in Java or any other language for deployment into the browser for business applications is that companies need to create standards for themselves. A standard internally for accessing a database, a standard internally for connecting the backend to the front end. And all this takes a lot of time, to create, to maintain, to debug, to test. And Java EE provides all of these different services itself, so that you can focus on the business domain of your application. So standards and specifications is the basic underlying idea of Java EE. Java EE is driven by Oracle, but there are many other companies and individuals involved with the process of coming up with the specifications and the standards. Your organization could also join in the standardization bodies and become part of it as an organization, or you as an individual programmer could become part of Java EE specifications too. It's a completely open process that anyone as an organization or as an individual can become part of. What's also great to be aware of is that it's continually being enhanced. And in the picture you see blue blocks and orange blocks, each block representing a different specification that is part of the Java EE platform. The orange blocks show the newest ones that have most recently been added and that relate in particular to HTML5. An increasingly popular front end for Java EE backends. So continually being developed in the open, and you can be part of it. That is the focus of what Java EE is all about. The second item we're going to look at are in slightly more detail what the problems are that Java EE tries to solve. Now, the problems relate in particular to standardization. And there are three aspects to this that relate to the three tiers of large applications that are deployed typically into a browser. So there's the data access layer, standardized way of accessing data and of making sure that the data that is entered back into the database from the application is correctly validated. Secondly, on the business logic layer, a standard way of connecting your database, your backend, to your view layer. And finally, your view layer. And on this level, there are standards that relate to how the data is presented to the user and how to connect that data that is displayed to the user to the backend of the application. Now, what all of this makes possible is that new members in your team, in a development team within an organization, can get started very quickly. Because Java itself is the most popular language in the world. There are over 9 million developers that make use of Java. And also, there are many developers that know Java EE, all these different specifications and standards. So if you need to get more people to join your organization, they don't need to spend time learning it when they join your group. Instead, they will come with the knowledge that they already have acquired from their previous work with Java and with Java EE in other organizations. The bottom line to all of this is that Java EE is focused on you not needing to reinvent the wheel, because the wheel has been invented already by the specification bodies, by the standardization bodies that are involved in the process, and you can benefit from that and focus very quickly on the business layer, on the domain layer of your application, instead of the underlying infrastructure and the generic concerns that are common to all applications. The third item to look at is, what do we need? What do we need to get started using this standardized approach to creating Java applications that are typically deployed into a browser? Well, first of all, knowledge of Java. Knowledge of Java is very widely spread. As stated, over 9 million developers that make use of Java. It's the most popular programming language in the world. There's a lot of information available, a lot of tutorials, a lot of experience all over the web. There's the official Java tutorial. There's also many tutorials on the NetBeans site that get you started with using Java. But you also need the time to learn the specifications. You need to invest some time whenever the new specifications come out in becoming familiar with them and learning what the new features are and then how to leverage them in your own application and how to migrate your own application to use the new versions of the standards as they are released. The third item is you need software. Firstly, we're going to look at the libraries and the frameworks that you typically need. Secondly, at the application servers. And thirdly, at the tools, the development tools that make it possible to very quickly develop Java EE applications. So first of all, the libraries and the frameworks. There's the Java EE jar. So it's a jar file that is the underpinning of Java EE that contains many libraries that provide the implementation of the specifications and the standards that make up Java EE. So there are jars that relate to data access. There are jars that relate to validating the data before it gets put back into your database. There are jars that relate to the business logic and to the view layer. And there are also external parties, external organizations that can make use of these specifications as the basis of their own implementation. So for database access, there is TopLink and Eclipse Link, which are based on the standards that Java EE provides. On the view layer, there's ADF, there's Prime Faces, VAD and Wicked, and many other view libraries that are based on the standards that Java EE provides. Either they directly implement the view layer specification, which is called JSF, Java Server Faces, or they create an alternative view layer that connects directly to the business logic and the backend of the application. On some level, all these different view layers make use of the specifications and the standards and implement their own functionality and their own unique features on top of that. Two other common tools and technologies that are used together with Java EE are firstly Maven and secondly JRebel. Maven is an Apache project and it's focused on providing predefined solutions for building and compiling and testing and running and distributing your application. So instead of using Ant scripts or some other scripting language, you can use the predefined goals that Maven provides for testing, for building, for distributing, for bundling JavaDoc and things like that. So it's a standardized approach to the build process and to the distribution process and the testing process of any application that makes use of, among others, Java EE. JRebel is focused on helping you develop your application very quickly. Instead of deploying the application, seeing it in the browser, closing down the application, making changes, deploying it again, you can deploy it once and just leave it running, make changes and refresh the browser, and immediately all your changes will be viewed. So JRebel and Maven, like all the other libraries and frameworks listed here, are really there to help you as a developer implement and be productive with Java EE. On the back end, at some point, you need to deploy your application so that it can be displayed in the browser. And there are various servers available for that. There's WebLogic, there's Glassfish, there's Wildfly, there's Tommy. Each of them are implementations of specifications that are part of Java EE, making it possible for the server to provide lifecycle services to the application. A lot of what an application normally does is handed off to the application server to take care of. When you are choosing a server, what's very important to be aware of is whether the server that you choose supports the version of Java EE that you are using. Currently, the version of Java EE is Java EE 7, and not all of the application servers support Java EE 7. So when choosing an application server, make sure that it matches with the version of Java EE that you are using. A third point is you need tools. You could use a text editor, but there are potentially many different files involved, especially as your application becomes larger. So there are tools like JDeveloper, NetBeans IDE, Eclipse, and IntelliJ IDEA, who all in one way or another make it possible to quickly and easily create Java EE applications. Each has a slightly different focus. Each has slightly different benefits over the other, since there are, after all, different tools created by different organizations. In general, though, most people would agree that NetBeans IDE makes it possible to very quickly get started and begin learning about Java EE. As a learning tool, NetBeans IDE is really well placed. It's developed by Oracle. It always supports the latest specifications, the latest standards. As soon as a new version of Java EE comes out, a new version of NetBeans IDE is also released. So in the demonstrations, we're going to focus on NetBeans because it makes it very easy to get started with Java EE. In the demonstrations, we're going to look at a couple of scenarios. First of all, we're going to look at how to set up a Java EE application. Secondly, we're going to connect to a database from our Java EE application, using the standards and the specifications that relate to that. Thirdly, you're going to learn about integrating business logic into the application, so the middle tier in a three-tiered application. And finally, we will look at the view layer. And in the view layer, we'll look at using the official JSF, Java Server Faces, official standardized specification from Java EE. So there's an implementation of that called Prime Faces. And we'll also look at an alternative way, which is to use HTML and JavaScript and CSS. And we'll see how that hooks into the backend that Java EE makes available. So let's get started with the demonstrations. Let's get started with a Java EE application. So as you can see, immediately we can start using Maven. So our build system will be Maven, not Ant, not Gradle, not some other build system. Maven, which is a very widely used build system when you're creating Java EE applications. We'll give our application a name, for example, Customer Manager. Click Next, and we'll click Finish. Before we do that, you can see that we have selected here Glassfish as our server, although we could use JBoss, so we could use Wildfly here. You can see here WebLogic, and we can also see that we can use Tommy. So, and there are plugins that make it possible to make use of other application servers. Also, you can see that we can use any of the different Java EE platforms available. So Java EE 7, 6, or 5 are typically, those are the three that are most widely used. Java EE 7 being the most recent one, the most up-to-date one. So that's the one that we're going to pick for our application. Immediately we can see that we have a list of goals. So these are goals that come from Maven. Maven comes with a set of predefined, bundled predefined goals for building, for running, for distributing an application. And here you can see them listed. So if you want to run, you can right-click and choose run and things like that, and build and compile and test. Our application contains right now one HTML file. For the rest, you can see that we have the JDK, and our Java dependencies are just Java EE. Our POM definition, so this provides the project structure based on Maven, lists Java EE as our Java dependency here. And for the rest, these are typical Maven content, so providing the compiler from Maven and that kind of support. So here the Maven compiler plugin, for example. Okay, so our application is actually started, the basic Java EE application. And now we can try and do something useful with it. Let's try and connect to a database. So we begin by looking at our database. What's very useful in NetBeans IDE is that we can register our database directly in the IDE and look at the data that is within it. You can create new connections. So you can see that we're using a database server called JavaDB or Derby, but you can see MySQL, Oracle can also be added here. So Oracle DB, Postgres, so the whole range are possible, or you could add your own JDBC driver. It's important to note that if you're using Oracle DB, registering it in NetBeans IDE is very simple, and you can also then explore your Oracle DB content and make changes to it. For example, in this case, you can see our tables, and here's our customer table. And here is the data that is in the customer table. And you can see also we can right-click, we can insert records, and this will insert records directly into the table in the database. So this is really a database management tool that is part of NetBeans. And it has very useful features. For example, a code completion. So if I'm pressing Control Space, I can write my SQL queries directly in here with the help of the code completion. So if I don't know what tables are available, I can just call up Control Space, press Control Space, and I can see the tables that are there. So I can change the SQL query and just click in there, and I can see the content. So let's change the query to something different. Manufacturer, for example. We'll run the query again, and now you can see we have a different output here. So these are the manufacturers. What we're going to work with is the customer table. And here are the customers. You see here the first three customers are called Jumbo Eagle Corp, New Enterprises, and Ren Computers. So what you want to create ultimately is a CRUD application, create, read, update, delete. Those are typical types of applications that you can use Java EE for very well. So here we can see our data, and next we can see our servers. So I have Glassfish up and running, and as you could see before, we could also register a different server. We can see the resources here, and once an application is deployed to Glassfish, we'll be able to see here a new node in this list showing the deployed application. What we can also see here are web services. So if you want to make a connection to a web service, we can either use, for example, the Amazon Web Services, the existing ones that are listed here, Google Web Services, or we can register our own web services. And then tools are added to NetBeans for creating skeleton code stubs for connecting to those web services. Moreover, we can connect to the cloud. So there's the Amazon cloud, but there's also the Oracle Cloud that you can connect to directly in here. You can connect to Maven. You can see the Maven repository and what is available, the jars that are available there to handle dependency management for you. There's the Hudson builders, so if you want to set up an instance here to build your application and view the results and manage that on a website, you can do that here. The task repositories, so you can add Bugzilla or Jira, so if you have issues in an online issue tracker, you can integrate that directly into NetBeans. And you can view your issues here, and you can put comments into your issues and mark them as being, and also link them into your code. So connect code and applications to issues. And there's also a test driver for JavaScript. So the first thing we want to do is we want to connect to our database. You can do this in multiple different ways, but in Java EE, it's standardized. So there's one standard way of connecting to your database, and there's a specification called Java Persistence Annotation specification. And there's another specification called the Bean Validation specification. Now you can learn about those, and as you learn about them, you can use NetBeans to try out what you're learning. So let's see here. You can see here entity classes from database. And this template, so I right-click on the project, I choose New, and I go to Other. I can go to you can see here, there's an item here, persistence. So these are all templates that relate to persistence. So here you will have entity classes from database. So what are these entity classes? These are Java classes that comply to the standard provided by JPA, the Java Persistence Annotation Standard. And within those classes, you will see annotations that come from the Bean Validation specification. So we can create all of that ourselves by hand, but this template will generate all of that for us. So this is what we're going to do next. So we select our data source, so our sample data source, and you can see if I go back here that this is the name of that data source. If you look at the properties, you can see here JDBC sample. So this is what you want to connect to. So right-click on it, entity classes from database, we collect to JDBC sample, and here are the tables that are in the sample database. We choose customer, we say add, and we can allow the related tables, so there are foreign key relationships on these other two tables to be included. Now what's going to happen is we're going to have 3 classes generated from our 3 tables. And you might ask, what happens if my table changes? If your table changes, you can come back into this template, and you will see then that there will be an additional option here. It will not only have new, but it will also have update. And if you choose update, what it means is that there already exists a class with your name customer, and what's going to happen is nothing in it will be changed. It will only be added to. So that class will be added to with the changes that you've made in your database. So if you've added new columns into the database, then new getters and setters will be generated for that column into that class. So this update will not delete any content, it will just add to it, because deleting content from your class would be quite a dangerous thing to do. Now you can see a variety of other things can be done. So a persistence unit is part of the JPA specification. It provides an XML file inside of which the connection to the database is defined in a standardized way. And you can also see that we could have if we use collections, if there are multiples of a particular item, then it could be in a collection, in a list, or a set. So there's a lot of configuration we can do, but let's just take the default configuration, and what we will now have are, first of all, you can see added here are the jars. So these jars are implementations of various parts of the Java EE specification. So Java EE has a JPA specification, as mentioned. So here are the jars from Eclipse Link that are being used, one implementation of that specification. Now we have, for each of the 3 columns that we chose, we have a class. So here is one Java class. You can see here this is actually a plain Pojo. So this is a customer class. And it has getters and setters, like you would have with any business object. So if you use business objects, domain objects, POJOs, plain old Java objects, you will always have a hash code, equals, and a toString with many getters and setters. The difference here is that there are annotations added to it, and these annotations are defined in Java EE. So, for example, you can see here that here is an entity annotation. So this will mark this particular class as being an entity, and a table, this marks it as being a table. So this is information for other parts of the application to be able to interact with it. Another example here is the column. So what we are saying here is that the maximum size of the address line column is 30. So if the user tries to enter into the database an address line value that is larger than 30, then an error message will be shown. Now this is made possible by the bean validation API. The bean validation API is part of Java EE and provides a common solution for handling the validation of values that go back into the database. So you receive error messages if these sizes are incorrect. So size comes from the bean validation. What also comes from the bean validation API is the pattern annotation. Now here, because we had a column in our database called phone, NetBeans IDE determined that probably in this case we are referring to a telephone number, and provided a suggested pattern annotation that defines the pattern to match in order for this to be a US phone number. The same is true for email. So here is a pattern that we are given to use optionally, so it's commented out. But this is a pattern that our value for the email column needs to match in order for it to be an email. And if it doesn't match that, there will be an error message and it will not be entered into the database. So you can see that on the one hand, in this case of email and phone and fax, on the one hand, the column annotation and the pattern annotation, which come from the bean validation API in the Java EE specification, help in providing a standardized mechanism for validating beans. On the other hand, NetBeans is very useful in generating a class that complies to that specification, and also gives you hints even, for example, in the case of the pattern annotation, giving you a hint of what you could use if you did want to validate the email column in your application. So what we can also see are rules like join column, many to one. So the relationship between the customer table, the discount code table, and the micromarket code table is also handled via these annotations. So here you can see one-to-many relationship with discount code. So it's mapped to discount code. And you can see that in each of these, what the class is mapped to. So all the relationships between the tables are expressed in annotations. The bean validation is expressed in annotations. And also we have named queries. So instead of using SQL queries in your code, we will instead use, for example, customer find all to refer to select C from customer C, which would be the SQL query. Now if we use here control space, you can see that here we have code completion as well, which makes use of SQL directly with the database. So here we see that we could also use these three tables instead of these two tables instead of customer. And here are the SQL query commands we can use. So there's an SQL query support directly within the strings inside of this class that was generated in NetBeans. Okay, so we have all the code for accessing our database. Let's now add some business logic that will complete this small demonstration. Before we look at the business logic, let's look at the persistence XML file. This is a file defined in the JPA specification, and it registers, first of all, the provider, the persistence provider, which in our case is EclipseLink. And we could choose a new persistence provider. And we can manage the libraries for this. So for example, we could have TopLink in here, or another provider for JPA, such as OpenJPA, which provides the services for connecting to the database. You can see here that there's a table generation strategy, so create, drop and create, or none. and validation strategy, whether it's automatic or not, and the caching mode. So there are various database services offered by these persistence providers. You can see here in a GUI component, but also in source view, that it's actually an XML file. And it's in a fixed position within the application in the meta-inf folder. So it's automatically picked up. We can also specify which of the classes should be included. And because we haven't specified any, we're saying include all entity classes. So what this means is we should be able to refer to our persistence XML file in Java code. And in doing so, via the persistence XML file, have access to our business logic. So here we have customer, discount code, and micromarket. We will not need to interact directly with them, but we'll be able to use a class called Entity Manager for connecting to them via the persistence XML file, as we're going to see next. So we begin and we start by creating, again using tools and NetBeans, the business logic layer. So we jump down to persistence again and we choose session beans for entity classes. Now session beans are part of the EJB specification, the latest one being EJB 3.2. EJB are enterprise Java beans, a standardized EJBs are standardized mechanisms for accessing data in the backend. So here we're saying we want to create these for our entity classes. So for each of our classes, we want to create a entity class, an EJB class. So we can see here that these are now being created. Now, to make sense of these, it helps to just look at them. There is a class called customer facade here, which simply has an annotation stateless. For the rest, it's a plain old Java class. It extends abstract facade. It's got stateless on top of it. And you can see here that we have access to a persistence context. Now, the string that you see in here refers to the name of the persistence XML file. Here it is. So when NetBeans generated these business classes, the EJBs, it did so by looking inside the persistence XML file. It saw that this was the name, and it put that name inside of the EJB. Now we can refer to that entity manager in our code, because here we have the EM defined. So let's add some business logic to see how we can use this entity manager. So we insert some code and we say add business method. So we say get customers. And the return type will be a list of customers. So here's a list of customers. We can get the import statement, Java util list, and now we can use this EM, which refers to the entity manager. EM, and now we can create a query. We can create a named query. Now remember our named queries. So here are our named queries. So what are the named queries? We don't have to look inside that class to find them. Instead, we can call up code completion here, and here we see the named queries. So here are all the named queries in all of the classes. So we want to call here, we want to say to the entity manager, call customer find all, because what it will do, we don't need to know this, it's implementation details, but what it will do is it will call this SQL query. And we want this to be a result list. So there we go. And here we have a get customers that we can call from the view layer. And once we do that from the view layer, we'll be able to call the entity manager and ask it to return all the customers. You can see here we will have a list of all the customers. So that's what we'll do in the next step. In this step, we're going to connect to our backend services that we've created. So we'll start by creating our JSF pages from entity classes. So here are our entity classes. Before we created our business logic, Now we're just going to create our front end. So the nice thing about standardization is we can generate a lot of code quite easily because every layer is based on standards and specifications. So the tools such as NetBeans can really fit into that very well. So for example, NetBeans can look, if a class has a stateless annotation, NetBeans knows this is an EJB. If a class has an entity annotation, NetBeans knows this is a JPA entity class. We click next, and so for each of these we will have created our special JSF front end. So we can say, so what's going to happen now is that session beans are going to be created, very much similar to the ones that have already been created for us, and we're going to say which JSF pages and where the JSF pages should be. So you can already see that files already exist in the specified directory, so we're going to put them into different places. So first of all, we will have here beans, and secondly, our JSF classes will be JSF. Now, we can also see that directly inside NetBeans we can specify that we want to use prime faces instead of standard Java server faces. So prime faces is a component library on top of Java server faces. We could say override existing files if we had existing files in those packages. We can customize the templates. So in each step we can say the templates that are being used here we can customize to add our own logos, our own footers and headers and things like that. We can specify the component library version we want to use, and we want to make sure that the jar that provides the prime faces components is available as well in our application. So for that we need to wait a moment to be added to the application. You can also see that instead of using JSF, we could use our own a different version of JSF, or we could create a new library instead as well. We can also specify that instead of using facelets, which are the front-end components, we could use the older JSPs, Java Server Pages. And the benefit of facelets is that here we can use style sheets directly inside of our view components, which JSPs did not allow. And there's also many other enhancements, but especially style sheets and the possibility of creating components is supported by facelets. So that's the latest specification in terms of viewing the data that is exposed via our business logic. So now we want to add prime faces. We've said we want to do that. And now here all of our code is generated. Now what was created before we don't actually need because so much has been created for us now. I'm just going to close this. So you can see here before we were talking about the customer facade. Now those facades are again have been created a second time. So here they are, customer facade, by this template. So we're just going to delete all of these ones that were created here. So either we can create just those business logic layers, the EJBs, or we can use JSF, the JSF wizard, which will create those, but which also creates our JSF pages. Now this is XHTML, and you can see here that we have what looks a lot like XML tags. Now these are prime faces components that you see here. So for our customer table, we have a create, edit, list, view. So this is CRUD functionality for the customer table. So this is the view layer. And there is CRUD functionality for the discount code, CRUD functionality for our micromarket. So for each table, we have a view, we have a JPA entity class for accessing the data, and we have business logic all set up for us to use. So if you look at the view, at the list component, you can see that a connection is being made from here to controller classes. And we can jump from here directly into those classes. So here's the customer controller. We have here generated a named annotation on our customer controller. And you can see the customer controller here. So here you can see we have getters and setters, we have create. So here we have the code that we were manually creating before. We have get items, which is referred to here. Customer controller items jumps us into the get items, which calls find all, and which in turn calls our query, our SQL query, to get all of our data. So from our view layer, we can jump directly into the back-end code, the Java code that is being referred to. And there's a special language, that facelets expression language, that is being used here. So first of all, we are specifying that this method needs to be called getItems, which will call the SQL query for getting all the items. And when something is selected, we have code here for setting the selected item. So here there's a direct connection between our front end and our Java code. Also, bundle files are used here. So you can see that our bundle properties files are hooked into our view layer. So again, this is all following the standards provided by JSF. So we should now be able to see some CRUD functionality when we deploy this application. So let's do that. We can choose our browser here. I'm going to choose the embedded browser. We could choose an external browser, but NetBeans has a browser built into it. And so we deploy the application, and in a minute we will see the browser start up, and we will see our Java EE application deployed into the browser, displaying our data in such a way that we can actually work with it. So here, first of all, we have the index page. So here's the index HTML page. We'll, for the moment, close the other windows here. And you can see here, these are just links into the other files that are part of this view layer. So we just click on the all customer, and here you can see are listed all the customers. So and these are prime faces components, which are very nice and provide additional functionality on top of standard JSF. For example, we can page onto the next set of data. We can create new data. So this nice component that pops up here comes from prime faces. You can see also it's very nicely styled. We can create new customers. So actually we have a complete application. We can also edit the customers. So if we can maintain. So here's the customer. So you can see edit. So if we select an item and we click edit, we get a form that displays all the data for the selected row, and we can change it. We can delete, we can just view. And the first three rows that we saw in the database, Jumbo, Ego Corp, New Enterprises, and Rain Computers, are actually displayed here, together with all the other data from the customer's database in a very nice view. Plus, we can jump. You can see what the HTML looks like, because this is the HTML is rendered by JSF, and each item that we click on in the browser DOM here, we can see where that is found within the embedded browser in the central part of NetBeans. So with that, our Java EE application is complete. It's all generated from a database, which is possible because every part of it is based on specifications and standards. And now you can really see the benefit of using Java EE. It's very beneficial for tooling, for creating a tool like NetBeans. And that in turn helps you to learn about Java EE and also to be productive in it. In the final short demo, you're going to see how to, instead of using these XHTML pages and these JSF components, you can use pure HTML instead with JavaScript and CSS. In this final demo, we're going to look at, instead of using JSF, using HTML5 and JavaScript. So again, we create our customer manager. So we'll call this one customer manager HTML. We click next and we click finish. We'll do everything that we did before, with the difference that this time we will create RESTful web services to expose our underlying data. Once you've done that, we'll be able to create an HTML5 front end. So where before we started with creating entity classes from database, and then we did session beans from the entity classes, and then we created JSF pages from the entity classes. We are now going to instead say RESTful web services from entity classes, or even better, since we don't have them yet, RESTful web services from database. So we point to our database as we did in the beginning before, and what this will do is not only create RESTful web services, but it will also create JPA entity classes. So everything is as before, except you will get more code. Now, to give ourselves a good picture of what's going on in our application, NetBeans also comes with a very handy Palm view. So we'll open the Palm and look at the graph to understand the dependencies and the relationships. So we show a graph. So these are the jars that we are using in this application. So we set the layout to hierarchical. This gives us a very clear perspective. So we have our Java EE jar. In addition, we have jars relating to JPA. So this is the persistence layer. Persistence, you can see here the persistence. Eclipse link is an implementation of the persistence jars. And we also have bean validation included here. Now, we have, as before, JPA entity classes. We have EJBs again because we have the stateless annotation, but in addition we have the path annotation. And the path annotation exposes this as a RESTful resource, this class. And you can see several of the getters have their own path annotation, so we can get to specific methods. This getter, the findAll, does not have its own path annotation, so therefore we can access it via the default path, the path of the class. So we'll make this slightly more usable and change this to customers. So if we have customers as the final part of a path in a browser, we'll be able to get to this findAll method, which will automatically be called and which will, under the hood, eventually call the SQL query to get all the customers from the database. How we get there is that there is an application config class, which again, according to the RESTful resource annotation, according to the RESTful resource specification, has an annotation application path web resources. And here are its resources. So these are the three resources handled by the web resources annotation. So if we have this inside of the path in the URL, followed by customers, we will get to our customers in the database. Now, we can see that we can either use an XML or a JSON payload. So we can process and work with the data as XML or as JSON. So here we'll pick JSON, and we'll pick how this should be, where it should be deployed to, so the embedded browser. And now we deploy the application. So what needs to happen is we have Glassfish needs to start up. So it's starting up very fast. So we have our database, we have our tables as before. And once Glassfish has started up, so we see our hello world, which is the index file, web resources / customers. And now we should see our JSON. So here is the JSON rendering of our customers. So the first one was named, here is all the details. You can see here Jumbo Ego Corp. So that was one of the records in the database. Now, of course, this doesn't look so great, and you can't do anything with it. And we could, again, create a JSF frontend that connects to the backend and works with this JSON. But what we can also do is we can create a JavaScript client. So we could create a RESTful client in JSF with prime faces. But instead of that, we can say, no, what we want is Backbone. So Backbone is one of the JavaScript frameworks available, which has as a speciality that it works with MVC structures very well. So if you want to use the model view controller paradigm for structuring a JavaScript frontend, Backbone provides good solutions for that. But what we now want to do is we want to generate that using the table sorter UI from one of our RESTful resources. So again, it's also everything is standardized up to from the JPA and the bean validation and the EJB right up to the RESTful resource. So now we can point to our RESTful resource and say we want to have a client generated. We'll also have an HTML generated for connecting and displaying our customers. Our index HTML as before. We have our customers HTML file. But importantly, we have a RESTful client. So this is inside of the same application that had everything else. So inside of our application with Java code, we can also just use HTML, and that uses JavaScript. So you can see here, this is the URL that we had before for connecting to the JSON, which is now parsed by this generated JavaScript. And you can see here the model view controller pattern. Let's again deploy the application, embedded WebKit browser. And we have here hello world. But now, so this is the index file. So now we're going to point to our customers file instead. Customers HTML. And here's all our data. Our data is now not rendered with the prime faces JSF components, but it's in pure HTML with JavaScript. And also, as before, what we can do, we have our browser DOM, and we can click and connect from the browser into this DOM. So here is a TD, here's a TD, here the table starts. So you can really analyze what you see here and relate it directly back to, so I'm browsing now in the browser DOM. You can relate the HTML you see here back to what you can see in the embedded browser. And now you have a RESTful JavaScript client on top of your Java EE backend, meaning that you can either choose to use the Java EE front end, which is provided via the JSF specification via facelets, which also makes it possible to use CSS, or you can use plain JavaScript and HTML, which can also connect to your backend via the RESTful resources that are part of Java EE. So in the demonstrations, we've seen how to set up a Java EE application. You've seen how to connect to a database. You've integrated business logic. You've seen how to do that via code, but also via code generators. And we've created a view layer using, in the first place, prime faces, and in the second place, Backbone. Backbone being one example of a JavaScript framework. You could use Angular or Ember or any of the other JavaScript frameworks for this purpose. In this session, you've been introduced to Java EE. It provides standards and specifications for working with all levels of your application. There are many additional resources that you could look at. There's the official Java tutorial, docsoracle.com/javase/tutorial if you want to learn about Java. There's the official Java EE tutorial that you can look at. So here's the URL to that. You can go to NetBeans IDE. It's free. It's open source. You can download it and start with it immediately. No plugins had to be installed for any of the demonstrations that were shown. Everything works immediately out of the box. That's one of the key strengths of NetBeans. So you can go there and download NetBeans IDE. And finally, there's a very nice book that you can also buy. It's called Java EE and HTML5 Enterprise Application Development. And this book shows the techniques that were shown right at the end of the demonstrations, how you can benefit from the strength of Java EE while leveraging your existing knowledge that might be focused more on HTML and JavaScript inside of the same application. And with that, thank you very much for joining the session, and hopefully it was useful, and have a lot of fun with Java EE, and with NetBeans. Thank you.